Hi, it's week 7, and we're moving on to grade 7, Chance, Processes, and Probability Models. I hope you had a chance to read that little section on grade 7 in the progressions document. Some pretty good stuff there. Students are building their understanding of probability on a relative frequency view of the subject. So they're starting with the proportion of successes in a chance process and actually starting with experiment and getting a good sense of that, the sense that the probability would be more accurate as you, in the long run, and the more trials, the closer the relative frequency gets to what the theoretical probability would be. So it's a really important thing to get that understanding of the difference between experimental probability and theoretical probability. I really love this section because it's a lot of fun. You can play a lot of games with the students, and it connects so well, gives them something to practice, a context with which to practice all that they're building with adding and subtracting, multiplying and dividing fractions and converting between decimal and percent, and all of those things, looking at all of these values on a number line and just building the general number sense and facility with all of that arithmetic. So let's take a look at the vocabulary that goes with this. So outcome is a really important word here. Any possible or actual result of an action considered. So an outcome would be flipping, what happened after I flipped a coin, what I got. An outcome would be I got heads or I got tails. And an event is a outcome or group of outcomes from an experiment. So an event would be I rolled a dice, and a second event would be I rolled a second dice. If I had a red one and a green one and I rolled them both, that would be two events, and each of them would have their outcome. A sample space is a organized way of spelling out all of the possible different outcomes. And we'll take a look at that a little bit in a little bit. So probability is defined as the likelihood that an event will occur. So that's the general definition there. So probabilities can be written as fractions, decimals, or percents. And students really need to get that down, that it's any of those. And ratio and proportion as well. So an event that is guaranteed to happen has a probability of 1 or 100%, and an event that has no chance at all has a probability of 0 or 0%, and things that might happen have probabilities in between. So this brings us to our first of 4 standards here. Standard 5, understand that the probability of a chance event is a number between 0 and 1. So basically understand that definition of probability and that fact that larger numbers indicate a greater likelihood, and that a smaller number closer to 0 indicates an unlikely event. So putting things on a number line and having students practice placing things. So have them make a list of events that they think, imagine some things. What are some things that are not likely to happen today? And place them on a number line where you think, and have them give a percentage or a fraction of what likelihood they think that is of happening. And if it's 50-50, place it there in the middle. And if it's really certain to happen, like they will go home today or they will eat something today, then they can put that closer to the one that it's very certain to occur, and then place things in between where their estimates might be. So that's kind of fun. That's the only I looked on the illustrative math site for an activity that goes with this standard, and there wasn't one. So this is the only thing that I came up with. All right, so on some more vocabulary, we've got experimental probability, which is probability based on data collected. So actually collecting the number of successful outcomes in the experiment. For example, if success is judged as we pull a red sock out of the bag of different color socks, and they're out of the total number of outcomes in the experiment. So perhaps there's 15 socks in the bag, and so that would be the total number. And then there's theoretical probability, calculated based on the possible outcomes when they have all the same chance of occurring. So what is the theoretical probability, knowing how many red socks are in that bag of 15 socks total? In theory, how many successful outcomes would you expect out of a certain number of trials? So that brings us to our next standard: approximate the probability of a chance event by collecting data on the chance process that it produces and observing its long-run relative frequency, and predict the approximate relative frequency given the probability. So there's an example there. And one that I really like to use is a mystery spinner. So I've got this spinner here with the purple, green, and orange, and the students cannot see what the fractions are. So I'm spinning them, and then I'm telling the students, okay, I did a spin on my spinner and I got purple. And then I ask them, was that enough to know what my spinner looks like? And they would say no. Okay, so we'll do 6 more, and I'll tell them which colors, and they're collecting that information. And so with this activity, it's really nice to go up to a total of 48, so it's nicely divisible. And then it typically gives students enough data, a large enough sample size, to predict what the spinner might possibly look like. So at that point, I give them an empty spinner page that looks something like this, and they have to decide how many segments of each color there should be. Kind of helps them piece together, well, with the experiment, what was the outcome? What's the expected? And they can get colored pencils and color them, and then they show each other and see how they compare. Now, perhaps they weren't next to each other, like they had several green pieces that were scattered all over the place, or their different shaded pieces are in different areas on the spinner, but in general, most students will get the same number of purple segments as each other, the same number of green as each other, and the same number of orange. So this builds that pretty nicely. So then a question that follows up with this piece here on predict the approximate relative frequency given the probability. So after they've determined the probability on their spinner and built their spinner, and I could even show them my spinner, and they get that confidence that they did a nice job, then we follow up with some questions along the lines of, well, if we spin this spinner 100 times, how many times will you expect to get orange? How many times do you expect to get green? And that speaks to that second part, predicting the frequency. All right, moving on to standard 7. 7 kind of expands on 6, and they sort of go together. So it's developing that probability model, using that to find probabilities of events, and comparing probabilities from your model to observed frequencies. So do they agree? This kind of is spoken about in the progressions about how lots of hands-on activities are really critically important. And once there is a strong connection between observed frequency and the theoretical probability, you can start moving more in the theoretical direction and start simulating probability experiments with technology rather than doing physical experiments. But at the beginning, doing lots of actual drawing cards, drawing beads from bags, flipping coins, spinning spinners, all of those types of things that you can come up with are really important. And those are good examples for Standard A, where you're developing a uniform probability model, where there's equal probability of the things happening. And so those are all good examples there. Now, B is speaking to where you don't specifically have, it may not be uniform probability. The example they used in the progressions was flipping a thumbtack. Well, it's not going to be equally likely that it lands on its flat end compared to the tip. In the example here, tossing a paper cup, how often will it land open-ended down, and how often will it be other? So these are things that are much more difficult to come up with theoretically, and it really forces you to rely on the empirical data, the observed and generated information. So now we move on to the big standard where we spend the majority of the time, Standard 8. Find probabilities of compound events using organized lists, tables, tree diagrams, and simulation. So with that, we're understanding that just as with simple events, the probability of a compound event is the fraction of outcomes within the sample space. So we're using models to organize and then find the number of successes out of the total. So here's a few models that we can look at. One is a systematic list. If it's a small enough bit of data, like this example here, you can come up with a list of all of the possible outcomes. This can be done pretty nicely with flipping coins as well. And with this list, we can see perhaps something considered a success would be the probability that one of the colors is green. And so you could see that we have 2 green outcomes out of a total of 6 outcomes, and we can generate our probability there pretty clearly. We can do an experiment and see how close we get to that. A nice thing is to have small groups collect perhaps 10 experimental items and then pool it all together as a class and see how close you can get to what you would expect theoretically. Another model is the probability table, and it's very important to note that this is for exactly 2 events. The possibilities of, we've got it's kind of like an area model, like an array, so it only works for 2 events, but it's a really nice way of organizing the information. This works really nicely with dice. If you've got 1 through 6 across the top and 1 through 6 down the side, you can get your 36 sums. I am out of time in this video, so I will pick up where I left off in video number 2.